Welcome to The Explainer. Today, we're diving straight into the engineering secrets behind one of the most visually striking building envelope systems in modern architecture. We'll be focusing specifically on the section drawings of the FWS 35PD facade system by Schueco, unpacking exactly how it achieves its signature ultra-minimalist look. Let's get right into it.
So here is the central puzzle we're trying to solve today. Imagine you have a staggering 400 kilograms of glass. Now, how in the world do you support all that weight on a frame that is just 35 millimeters wide? I mean, that is literally barely wider than your thumb. It's the ultimate architectural conflict, really. We have this massive desire for extreme visual transparency, clashing right up against the strict, unforgiving realities of building physics and gravity. Here is our roadmap for the explainer. The Panorama Design system, mastering thermal insulation, decoding Mullion section drawings, decoding transom section drawings, and finally, heavy-duty structural reinforcement.
First up, the Panorama Design system, a macro view of maximum transparency. Okay, let's take a look at the baseline capabilities. What you immediately notice is that ultra-slim 35mm face width, which somehow, incredibly, manages to accommodate glass thicknesses starting from 22mm all the way up to a massive 15mm. You've got these beautifully overlapping planes of glass and just an unbelievably slim profile. It's engineered as a continuous system designed to attach directly to the building structure, and it even features color coding to keep installation simple and fast on site. But, before we really break down the physical framing holding all that glass, we need to talk about some of the invisible forces at play.
That brings us to mastering thermal insulation, balancing slim profiles with energy efficiency.
The system is actually divided into 3 distinct thermal tiers. The standard system gives you a U value of 1.4 by using a pre-assembled pressure plate. But if you step up to the high insulation or HI tier, that U value drops to 1.2 thanks to the introduction of a reflective foil. And then we have the big one, the super insulation or SI tier. This one drops all the way down to a staggering 0.88. Hitting a U value of 0.88 on a metal frame is an incredibly rare feat, and they pull it off by utilizing a specialized PVC/PE foam isolator alongside the reflective foil. The main takeaway here? This ultra-slim design absolutely does not sacrifice energy efficiency for aesthetics. In fact, that 0.88 U value on the SI tier actually earns the system an official Passive House certification from the Passive House Institute over in Darmstadt, Germany. That means it dramatically reduces heating loads, a pretty massive achievement for an aluminum profile that's only 35 millimeters wide.
All right, time to put on our engineering glasses, decoding Mullion section drawings, the vertical X-ray.
This is where things get really fascinating. We're looking at the section drawings of the FWS 35PD now, specifically the standard Mullion detail. Notice exactly how the 35mm external profile at the very bottom tightly anchors into the glazing rebates. It's like a giant puzzle, where the internal geometry, the continuous gaskets, and that central screw channel all work together to perfectly align the system. The glass edge cover you see here complies with all standard regulations to maintain a 12mm cover, but the overall face width still manages to remain incredibly minimalistic. Now for the horizontal supports. Decoding transom section drawings, the horizontal X-ray. Comparing these transom section drawings side by side reveals a lot of the system's nuance. We have the level 1 transom section on the left and level 2 on the right. Just look at the exact, really subtle changes in those central extrusion profiles. Those tiny geometry shifts are totally necessary to securely step the glass planes. Using these different levels allows for proper overall ventilation and drainage across the whole facade grid. It basically channels moisture perfectly through these highly engineered internal cavities. And thermal performance actually alters these horizontal lines directly. Taking a close look at this high insulation level 1 transom section, you can actually spot the integrated isolator profile sitting right in the center, sandwiched between the internal aluminum body and the external pressure plate. That specific piece of engineering, combined with the pre-assembled pressure plate and gasket, is exactly what brings our thermal value down to that strict 1.2 mark we discussed a minute ago. It's just a beautiful marriage of structural integrity and thermal management.
But what happens when standard extrusions just aren't enough? Heavy-duty structural reinforcement, engineering for massive spans.
We definitely need to distinguish between standard setups and the heavy-duty or HD options. While a standard transom is perfectly great for a normal facade module, modern architecture often demands these massive uninterrupted glass spans. to hit that staggering 400 kilogram maximum load capacity per pane. And remember, doing this without widening the 35 millimeter face width, Schueco utilizes internal rectangular steel tubes to securely and safely transfer those massive loads right back to the building structure.
Treat this incredibly dense section drawing of the FWS 35 PD like a true structural X-ray, because what we're looking at is the ultimate backbone of the entire system. This is a high insulation mullion section, but if you trace your eyes to the large rectangular cavity at the top of the profile, you can see it's absolutely packed. It contains both an aluminum insert profile and a heavy-duty steel reinforcement. All of that hidden muscle is entirely concealed inside the wall, leaving only that pristine 35 millimeter face exposed to the elements and the viewer.
All of this intense engineering density culminates in one core promise straight from the source documentation: maximum transparency due to minimal face widths. When you really grasp the sheer engineering required to pull this off, the thermal isolators, the nested drainage levels, those hidden steel reinforcements, it totally makes sense why this system is targeted toward highly representative luxury residential and commercial projects. It is a premium, no-compromise solution to a very complex physical problem. And that wraps up our explainer for today. We've journeyed all the way from the big picture aesthetics right down to the millimeter-precise section drawings. Now that you understand the hidden, heavy-duty mechanics actually holding up those massive 400 kilogram panes of glass, how will you integrate this 35 millimeter structural marvel into your next design? Thanks so much for joining me as we unpacked these incredible section drawings, and I will catch you in the next explainer.